Awesome, everybody. Welcome to this very exciting stream with CoinFund and Socket Supply. My name is Jake Brukhman. I'm the founder and CEO of CoinFund. We have been a blockchain-focused investment firm since 2015. Today, I have as my guests Paolo, Fragomeni, Scott Bloom from Socket Supply, which is a CoinFund portfolio company. And I'm super excited for them to tell you a little bit about themselves. And then we'll launch into what Socket Supply is. It's an open source tool that allows developers to build truly decentralized applications using a Web3 approach. Paolo, let's start with you. Give us a quick intro.
Hey, so in 2010, I left MIT to found my first startup. It was a platform as a service. And since then, I've been heavily involved in systems and open source, decentralization, peer-to-peer. For almost 20 years, I've been doing peer-to-peer stuff. So this is very exciting, and Socket Supply is really the culmination of a lot of the work and research that I've done in peer-to-peer.
Awesome, thank you. What about you, Scott?
Yeah, Jake, thanks for having us. Scott Bloom, I'm CRO here at Socket Supply Co. I've been working in startups for 10 years. We've worked at a bunch of awesome startups, Zenefits, Brex, a great fintech company. Most recently, I was working in Web3, actually at a company called CoinFlex, which has been in the news recently. But yeah, got my feet wet in Web3, understood distributed systems and decentralized systems. Met Paolo a couple months ago and, went out to Berlin, flew out, met him. We're grinding on a peer-to-peer tools, and we're excited to tell you guys about how they can help your business today.
Awesome, fantastic. Welcome, guys. So it's an exciting time. I think, if you ask me, there's a bit of a resurgence of peer-to-peer architectures. I mean, maybe like 20 years ago or 25 years ago, we've seen some of this come to the market with things like Napster, etc. But over the last 20 years, people have not preferred peer-to-peer architectures. Building peer-to-peer applications is hard. And so I'd love, Scott, you were going to show us some slides to give us an introduction to Socket Supply and how it helps developers solve this problem.
So the first thing I want to talk about is nothing is decentralized yet. I think if you know that everything is really running in central cloud providers like AWS, GCP. A lot of Web3 is built with those. Socket changes everything. I know it's a big statement, but I want to talk to you guys today about how we're doing that. At first, it starts with what's required to build a decentralized application. First, it needs to be able to run on everything. It needs to be able to run cross-platform on desktop, on iOS, on Android. It needs to be on all the users, all your peers in a network. And then number two, you need to be able to reliably connect all those peers, whether it's a server or a phone or a desktop, whatever type of computer, you need to build those things reliably. The story of Socket Supply is pretty funny. We sought out to actually just build tools on top of existing runtimes and existing libraries that were out there. And we just wanted to build tools that were going to allow developers to easily build peer-to-peer applications. And when we started to do that, we realized things weren't working. Electron was a runtime that was cross-platform we were trying to use, but it was only on desktop and 150,000 lines of code. We tried to use Hyperswarm as a P2P library, and it just was broken. We couldn't get it to work. We actually tried Lib2P2P protocol labs, and that didn't work either. We were trying to connect two devices in a room in Switzerland, and it wasn't even working. So we had to actually build these things foundationally. So over the last year and a half, we've just been building a cross-platform runtime and a reliable P2P library. So those are the two tools. The runtime, Socket runtime, is you write once, you run it anywhere. You can use a web developer. So front-end developers, web developers, you can write in the web stack and run anywhere. So a web developer can deploy to Windows, macOS, Linux, iOS, and Android. That's pretty crazy to think about. So now you can really empower any type of developers or all the web developers out there to build peer-to-peer applications and deploy anywhere. Most importantly, though, it's P2P, UDP, and Bluetooth enabled. That is probably the most important reason of this runtime. And so what that P2P library is Stream Relay. So that allows for static, easy, and hard NAT traversals, extremely complex things we'll explain at another time. But most importantly, that P2P library allows all those devices to get connected reliably and really create true decentralization. I will say you can kind of crawl, walk, run if you want to. Companies can use web socket runtime with their own backend if they want. But if you really want to go for like kind of like the holy grail would be socket runtime using with Stream Relay as your backend and getting rid of the cloud complexity and cost that you have today. I just want to go through just a couple slides about where the world is. Everyone wants to be cross-platform. All your users are across desktop and mobile. But in order to get there, it's complex. You need to hire, you need to find them, you need to hire them, you need to ramp them, they need to build it, and then you need to deploy. There's a lot of things and there's a lot of time and a lot of cost to build cross-platform. So this is a quick little slide. You got to hire, ramp, deploy. The negatives is it's expensive, it's slow, you know, less product releases, multiple code bases. And so that's what socket runtime fixes. You can write once, run anywhere with a web in the web stack. So a web developer tomorrow that you already have can just deploy to desktop and deploy to mobile for you. The positive outcomes for your business, you use the people you have or just hire one web developer right in the web stack and you're going to be faster to market, lower cost, faster user adoption, increased revenue, whatever your key metric here is, that's what's going to be. And then it's going to minimize risk. One code base is better than multiple. Here's a little metrics. When we send the slide deck out, you guys can have it. But your current state, you need multiple developers versus using socket runtime, you need one. You need over 3 or more, I don't know, specialized developers. You don't need any on runtime. Time to market's faster, less code bases, and your backend can be what it would be. I guess I would ask this question. What if you were able to deploy where you want with the web developers you already have? Would you do that? We think the answer is yes. Socket runtimes versus other runtimes, we talked about this. You need to be cross-platform. They are not, so we couldn't use Electron at first. We had to build our own. So across desktop and mobile, and then most importantly, these check marks enable Stream Relay, our peer-to-peer library. So Stream Relay, peer-to-peer library, connecting all your devices reliably. You can begin to transition away from those cloud providers onto this backend. You can continue to use the ones you have, but you know, it really, you're going to see a lot of benefits of using Stream Relay with socket runtime. Here's the little metrics. Your infrastructure, you know, your infrastructure today is cloud. It's expensive. Monitoring tools, people, infrastructure, peer-to-peer. It's none of that. You're not decentralized. With us, you are. Your costs are just a lot more than just working with us and then your web developers. So that's all I got. I think that was pretty good. Demo, building a cross-platform app using the web stack.
Awesome. Thanks, Scott. Paolo, you want to run us through the demo just so we can get our eyes on this framework?
Yeah, for sure. Let's see. Should I turn? I can turn this off, and then I can share my screen, and then. Okay, so here's our website for the project, native apps for desktop and mobile. So most web developers are going to be familiar with something like npm. So we'll install it with npm. So single command there gets it installed, and after it's installed, we can make a little directory to do a little experiment in. We have a little tool that's kind of like create React app, and so that'll create some boilerplate for you, and then we can kind of see what the boilerplate was that was created. So every web developer is going to be familiar with this. You've got some HTML, CSS, and JavaScript, and then in this simple JavaScript, you just have a content loaded event. And we'll use our API to tell us what operating system we're on after like a little timeout. And then there is a configuration file. And so since every application should have a unique name, we'll give this one a unique name and edit that and save it. And let's launch the demo app straight out of the box just to see what it looks like. Okay, so that's pretty simple. So it says hello world. And then after a little timeout, it tells us what operating system we're on. Cool. So that's a native app running on Mac OS. And this works for Linux and Windows and iOS and Android. But that's not very exciting. So let's make some edits to this and like make it do something that's kind of a little bit more interesting. So we go into the index file. Maybe we could delete some of these things that we just ran, make some changes here. And so we could use the peer-to-peer stuff that Scott was talking about. This is in the experimental section of the library. So what we'll do is start off by creating an instance of a peer, and that'll take an ID and listen to a topic, and we'll make it asynchronous. And when the peer receives some data, we'll call this on data event, and that'll tell us where the data came from. And it'll have the port and the address. And then after we initialize that peer, it'll start listening for connections. When we click on the application we want to do something, we want to create a random color. And after we create the color, we want to send the color to the network, to the other peers. Okay, so then when we receive a color from another peer, we want to make sure that it's if it's not us, if it's not our address, or if the address that's being sent is not the peer's address, then we want to filter it out. And then we'll run this. And there we go. When we click on it, we can see that the background of the document's changing colors. So that's pretty cool. But in order to demonstrate it being peer-to-peer, we want to make it also compile for mobile. So we can make a few edits to the configuration file here and add in some of the details that we need for running mobile. So we'll get rid of the boilerplate, and we'll just add in some of the details for iOS specifically. So we'll save that, and then quit out, and then compile, and then specify the command line arguments for iOS. So we want to compile it, we want to code sign it, we want to package it, and we want to notarize it. So all of that just happened, and then after that happened, we're gonna switch over kind of to a different view here, because it's sort of hard to see both the mobile phone and the desktop at the same time. So this is going to install the app. So we ran that command, and there it is. It's popping up on the phone. And then when we open it, we can see, okay, cool. This is, when we tap the screen. Okay, so here's both of them running at the same time. And when we click on the desktop, we see the colors changing on the phone. Cool. So that's both of these things in action together, with absolutely no servers involved or required. Applications are able to communicate with each other, and it really opens up an entirely new class of application that can be built. I realize that there's a lot of people out there with a lot of products that are built on the cloud, and like Scott said, it's possible to build applications where you continue with the existing infrastructure that you have, but then you incrementally move into a more distributed, more decentralized peer-to-peer architecture. And most companies, cloud is one of their biggest cost centers and the biggest amount of risk to your business. So being able to get away from that and being able to regain that autonomy, that ownership over your product, is a big value add, and we think that people are going to be excited about this. And in general, it really moves forward the entire agenda of Web3. Being able to create software with absolutely no infrastructure, cloud infrastructure requirements, can open up just a lot of really interesting possibilities.
Yeah. I think, Jake, I saw in the news this week. I want to share my screen one more time. This article, and I was talking about it with Paolo. But it was, can you guys see that? It's Why We Are Leaving the Cloud by DHH, founder of Basecamp. And I just thought that was a pretty powerful, like an entire article, why they're leaving the cloud. They're accounting to explain exactly how much like their cloud costs were, how out of control they were, and how it just wasn't economical to be there. So to see people already doing it, like publish articles and like being like, hey, like there is other options, you can run it yourself. That's like just further validation to us that we're seeing that's just like, hey, there's another way to do this.
I think it's interesting, or it's important too to point out like a few things that we've solved that are really critical to making peer-to-peer work for everybody. So one, of course, like a good developer experience. You're taking the web, which is the most abundant, most ubiquitous, biggest developer community that exists. Best documentation. The web is it's always a good bet. But yeah, so taking the web, the average web developer, and giving them this ability to create peer-to-peer architecture in a way that's dead simple is super important. But then also solving the small network problem is really important. So say, for example, two people, Alice and Bob, are chatting, and Bob goes offline, but Alice wants to continue to send Bob messages. Usually in a peer-to-peer situation, Bob just doesn't get those messages anymore because he's gone offline, right? But in the architecture that with the peer-to-peer protocol that we've created, it makes it possible for Alice to continue to send messages, and then when Bob comes back online, he will receive them. So we have a highly partition tolerant protocol that's really really resilient and easy to use.
Yeah. So Paolo, let's dive into that a little bit. Coming from a Web3 context, we hear the word decentralized a lot. I think a lot of people associate decentralization with blockchains, but obviously there's many different kinds of decentralized networks that we can build. Can you talk a little bit about, and you sort of alluded to it already, but what makes socket applications decentralized, and what is it about the substrate that they run on that is a decentralized network?
Right. So what defines decentralization is a symmetrical network where there isn't a single node that's more important than another node. In fact, any node from the network could be destroyed or partitioned or removed, and it wouldn't disrupt the network in any way. That's true decentralization. And today what we have is a lot of server to server. And what we really want is we want to start leveraging this massive amount of emergent hardware that's around us. We want to start to leverage that. There's more hardware in the world today than there's ever been before, and that's really part of what's making it possible for this all to happen. So what you could think of Socket as is not only a platform for creating cross-platform software, and then a way to connect that software for users to be able to connect to each other. But you could think of it as almost a layer 0 or a layer -1. And all of the software that we're interested in running, whether it's written in C++ or Rust or any of these things, they can target WASM and they can all run inside Socket applications. So if you have blockchain technology, or if you have games, it really doesn't matter what it is that you have. We can run it on mobile, desktop, on any platform, and have it connect, and without the cloud at all. And so, there's a really very large opportunity here for us to really recapture the margins that we'd lose when we're paying for infrastructure.
Yeah, computers got pretty expensive. Renting computers got pretty expensive, as they say.
So this is where it would be great to, Scott or Paolo, to dive in here, because when you go to a customer, and whether that customer is a smaller development team who's trying to create a peer-to-peer application in Web3, or a larger enterprise that, is looking for technological solutions that might leverage peer-to-peer technology or decentralized technology to save costs, like my question is, what is the mechanism by which they're saving all of this, sort of operational cost?
Yeah, I think there's two things for that. I'm gonna take the first part, and then Paul, you can talk about some of the people we're talking to already. So in terms of like their use cases, there's going to be similarities between both, but like you're going to have Web 2 use cases and you're going to have Web 3 use cases. I think most importantly, socket runtime is pretty obvious. Like write once, run anywhere. Like you're just going to get to market faster. You don't need to hire different developers. One web developer versus like 3 or 4 specialized developers. That's like a lot of cost for anyone. So that's like kind of across the board. And then you're just getting to market faster. So if you're getting to market faster, that's user acquisition, that could be revenue, it could be just customer experience, customer sat. You're just getting product releases. You're shipping faster. That's what everyone says, shipping faster. Like this is shipping faster. You are writing once, running anywhere. You can't ship faster than that. Like, and then costs, like infrastructure costs. So like as Web3 companies are, they don't make that much money. There are a lot of them, they don't make any money. And so their burn is high. Like they need to be able to like lower their burn. Their burn is probably AWS. That's probably their number 1 line item. So if you can reduce their top line burn to nothing, I mean, people can exist longer. So I think it's just way bigger than that. And then we talk about a lot of just like moving those resources. Like let us take care of the back of the house. Like it's done now. They codified it. I think Paolo, you said it yesterday. Like, we've codified the back of the house, so you can take those resources to the front of the house and build cool applications and product. So the use cases, there's true decentralization for Web3. You want to be decentralized? Now you can say you're decentralized. Like that's important to a lot of people. It's important to us, and so it's just the first time this technology has been reliable and available. Just like even a web developer to build is so crazy to think about. So it's just way bigger than just a metric or something.
That's a good point. It's like, peer-to-peer isn't new. Peer-to-peer has been around for quite a long time. And the web has been around for quite a long time. So these two things have proved themselves really well. And what we've done is we've just been able to connect all of the parts like really well, make them reliable. BitTorrent network is a really awesome network. It's super reliable. It's hugely scalable. The web, I'm really preaching to the choir if I start talking about how great the web is. But these things we've just found the right way, the happy sort of place that they kind of connect to each other. I think that like people have started to be quite interested in what we're doing, especially in terms of we're talking to quite a few people right now in the public sector. I won't get specific about the 3-letter organizations that we're talking to, but they're quite interested in the ability to, in a very quick way, spin up infrastructure that's not reliant on any particular geographic, locality, right? So, if let's just say, for example, there's some regions that aren't accessible, and that means that there's no data center to connect to, then you can still create a product. You can still create it, deploy it, and use it really quickly. So that whole cycle of creating, deploying, and actually using it is reduced by not needing to spin up this complex infrastructure. So, even if you're using something like configuration as code, or if you're using something like Terraform, there's still an enormous amount of complexity in that, and the expertise needed for it is pretty significant. So, reducing the total number of moving parts in a system is really a big part of why people are really interested in this. And obviously a lot falls out of that, like cost and reduced complexity.
Yeah,
awesome. And so you mentioned. Oh, sorry. Go ahead, Scott.
Yeah, I was gonna say, like, people know about this. Like, this is like libp2p is well known. Protocol Labs is well known. People have tried. Like, this is something that there's people trying to solve, but like just hasn't been successful. Really hasn't gotten there. And like, this has gotten there. Like, we're ready. So like, we're excited to like we can
for libp2p in particular. I think, to be fair, like a lot of what they were doing is really has been meant to be on the server for a really long time. Like there's a lot of demand on the compute side for what they were doing with their nodes. So it makes a lot of sense that it was server to server. And the reason why we really haven't seen peer-to-peer, emerge as much as it really should have is that browsers are just really, really, really difficult to get features like this into. It could have been possible, but it's just never happened. And the number of parts and the way that they need to come together just is just almost with 100% degree of certainty just never going to happen in the browser. So now is the first time where we're able to see peer-to-peer happen on a mobile device that can talk to a set-top box, which can then talk to a desktop, which can then really create this.
Well, this is exciting, and I would frame it maybe like there's a lot of decentralization technology out there, Scott. There's IPFS, as you mentioned. We talked about blockchains. Like a lot of these technologies are infrastructural. Like they have not focused on what is the process by which we actually bring applications to market? What is the what is the pipeline for applications? Like when you look at a blockchain, very focused on consensus, very focused on validation, economics, nodes, but has no particular opinion about how an app should work on top. And in fact, there's a lot of networks that try to facilitate that process. Like if people are familiar with the graph, what the graph does is it indexes blockchain data to make it really easy to use inside of a front end of an application. But even the graph doesn't give any opinion about how a Web3 application should work, how should it be structured, where should its data live, what platform should it live on.
Yeah, so imagine being able to run the graph on a tablet, or imagine being able to have a whole network of graphs, all doing what graph does, but without any need to have any SaaS behind it. I look at a lot of really potentially interesting products in the Web3 space that are very cool, but they're SaaS products at the end of the day. And so I think what would be very cool is to see some of these companies who are building SaaS products, but could have a huge upside from decentralizing to build applications using the web technology that they already understand, to put together a socket app and completely escape that cost and that constriction of the cloud.
Yeah, absolutely. So we have about 5 minutes left in this stream, and I want to ask you guys 2 more questions before we part ways. So one is just about customers, right? You mentioned there's Web 2 use cases, Web 3 use cases. Can you talk a little bit about specifically what kind of use cases you're going after, and who are you working with today as customers?
Yeah, well, we had some early kind of conversations with Bloomberg. So Bloomberg, has a terminal product that they create, and they've been working tirelessly to squeeze performance out of that, out of their product. And with the parts that are based on Electron, it's an aging code base, about 10 years plus. And so there's some interesting opportunity in potentially working with Socket to replace that. We're talking with the folks who are working on MetaMask, and we're talking with people who were working at Uber. We're talking with, the list is kind of too long for this call. Actually, it's started to grow recently as we've open sourced. And so people are coming to us, and they're actually asking us, like, kind of early adopters who are really interested in building something, because it's really a low switching cost, and it's a very low risk. So it's very easy for people to come and jump in our Discord and just be like, hey, how do I do this? Or, is it possible to do that? Or, that sort of thing. So that's really kind of where we are.
Okay, awesome. And then one more for the some of the developers that might be listening. You mentioned Stream Relay, which is Socket Supply's peer-to-peer library. Can you guys talk a little bit about, how does this library differ from libp2p itself, or maybe something like Filecoin?
Yeah. Well, Filecoin is a higher level type of thing that would use libp2p. So libp2p and Stream Relay are more kind of apples to apples, and Stream Relay is fundamentally has 2 characteristics to it. One, it is able to do NAT traversal, and it's able to do that very efficiently, and it does so over UDP. So hard NATs, easy NATs, static NATs, in every combination, it's able to hole punch through all of those, and then connect peers together. And once peers are connected, the next problem that you really want to solve is being able to send data packets with a reasonably high degree of reliability. And so what we're able to do is we're able to create a network where there's a shared responsibility of relaying between peers that have the capability, like easy NATs and static NATs, the packets if they're not able to be received. So we have a whole spec for this. I think we're the only peer-to-peer library that has a specification, actually. And the entire library clocks in at under 1,000 lines of code. With a specification and lots of tests. So, I think that this is the big thing that we really wanted. Like Scott said, in the beginning, we tried to use Hyper, we tried to use libp2p, tried to use these things, and using them over mobile is particularly tricky. And so, getting mobiles to talk to desktops is really important. Most of the people in the world are on mobile, right? That's where your customers are. And so we needed that, had to exist. And so getting all this stuff to play nicely together meant creating this peer-to-peer library. And so, so it's really very low level, and it only does a few things. And that means that, with our opinions, we have very few of them in there. That means that there's more room for your opinion. So if you want to build something and you need us to be out of the way, that's a big design goal of the library is to try to be out of your way and to do as little as possible, only what's absolutely necessary.
Awesome. Thank you so much, Paolo and Scott. Thanks for joining us. Folks, check out Socket Supply on Twitter. Check out socketsupply.co, which is the website. If you're a developer and you're looking for open source tools, to build truly decentralized applications, and to do it in a simple way that gives you, cross-platform capabilities, simple technologies like JavaScript that allow you to easily and quickly bring this stuff to market, and to save a bunch of money on infrastructural operational costs by using decentralization technology and peer-to-peer networks, definitely check out Socket Supply. Guys, thanks so much. Thanks for the demo, and look forward to seeing you again.
Having us.
All right, cheers.